Okay, so hello everyone. You are welcome to today's lesson. And today's lesson is going to be lesson 3 of coordinate geometry 1. Okay, in our previous lesson, you realized that we looked at how to extract the equation of a line, okay, based on certain parameters. However, in today's meeting, we are basically going to attain 3 main objectives, or 4 if you like. Okay, by the end of today's lesson, the student should be able to find the gradient of a line given its equation. The student should be able to determine whether lines are perpendicular or parallel. Okay, when given 2 points and when given the equations of the lines. Then, okay, the student should be able to find the point of intersection of 2 lines. And last but not the least, the student should be able to find the equations of parallel lines and perpendicular lines. Okay, so please take notes. This will be our core objectives, okay, for today's sports lesson. Okay, so as you can see on your screen, we are going to look at the first, okay, concept which will help us attain our first objective. Okay, so now we are going to look at finding the gradient of a line given its equation. Like I said, this is not new to you. Okay, it's a concept that you know in JHS, only that we are going to build up, and I'm going to shape your presentation as well. So quickly, let me read. Okay, to find the gradient of a line given its equation, we adapt the following steps. So step 1, express the given equation in the gradient intercept form. Okay, i.e., y is equal to ms plus c. So any line in the gradient intercept form will take, okay, this form or will have this behavior. And how do we do that? By making y the subject, if necessary. And here, this is there, because sometimes the question will come with your equation already written in the gradient intercept form. So that step will not be necessary. In that case, you move on to step 2. And step 2, what do? We compare your results, okay, in step 1 after making y the subject in the given equation. Okay, meaning after writing it in the gradient intercept form, you extract it with the gradient intercept form formula. Okay, and you compare and take the coefficients of your x as gradient. So compare and take the coefficients of x as the gradient. So you compare and take the coefficients of x as gradient. So as simple as that. Make y the subject. Okay, however, when you make y the subject, don't let y made the subject on the other side, the expression on the other side, be a single fraction. It should be partial fraction, because in the gradient intercept form, okay, we have partial fraction. So each term, if you have 2 terms, each term should be explicit. Then after doing that, you go and pick the coefficient of your x, okay, which will coincide with your m as the gradient, as simple as that. But take note, not all equations, we've realized that not all equations will have x, okay, term in it, or y term in it. We can have an equation strictly containing only x, okay, and strictly containing only what? Y. So if you have that situation, this special situation, how do we determine the gradient? And that will be catered for by the note here. If the gradient of the equation is 0, if it contains no term in x. So if your equation contains no term in x, then the gradient will be what? Will be 0. Take notes. Okay, because you know the gradient will be the coefficient of x. There is no s term, and once there is no s term, it means its coefficient is 0. It's 0x. That's why we didn't write it. Is my point well made?
Yes, please.
Okay, then 2. The gradient of the equation is undefined or infinity if it contains no term in y. So if immediately you can say that the equation contains only x. It means you cannot make y the subject. You can't even start, okay, the first step, not to talk about the second step. So immediately that's, okay, is the situation that you are confronted with. You should know that because you don't have y to make y the subject, and therefore pick the coefficient of x as gradient. Okay, the gradient will be undefined or infinity. All correct?
Yes, please.
Okay, very good. So now, if that is the case, then we can quickly go and have a look at the following question. Subject the following questions through, okay, the concepts that we've learned here, especially the steps. Okay, so this is what we have. The very first equation, find the gradient, sorry. Okay, so this shouldn't be, let me see. Okay, all right. So that's the first question. So find the gradient of the following lines. Find the gradient of the following lines. Find the gradient of the following lines. So here are the lines. So quickly, let's go and look at how best to solve what we have here. So as usual, when you read questions, you make it a point to underline salient parts, if any. And here we can see that basically we are asked to find the gradient. So you can choose not to underline gradient. That's what you are asked to find. Okay, so, okay, I come in having realized that no salient parts, or if you want to take gradient as your salient parts, you underline. Now, what do? We come and write solution. Sorry, then, okay, major question number 1. Okay, minor question number A. Remember, questions are numbered because equally you want you to number your solution. So now we extract the equation. So we write given, and the equation given is y is equal to 3x, okay, minus 2. That is our equation. Okay, so at this point, we are good to go. Remember, we said this equation first. First step, we have to write it in the gradient intercept form. Gradient intercept form. But you can see that this one is already in the gradient intercept form. I hope you are with me. Y is made a subject, and you have to. So the first step is not necessary. So that's why you can see that I wrote if necessary in bracket. So I will label this one as equation 1. It's just for a purpose because I will compare. However, immediately I mature, I will stop doing this. Okay, very soon you will know. Okay, all right. So now what do? We are going to write comparing. Okay, our equation 1 with the gradient intercept form of the equation of a line, which is y is equal to mx plus c. Okay, if you compare, we are going to get what? Our m to be equal to what? 3. So comparing m is equal to 3. All correct? M is the coefficient of x. So in this case, you draw your conclusion. Therefore, 3 is equal to what? The gradient. Because we're asked to find the gradient of the line. Okay, so gradient. You can choose not to add line, or if you like, you can write gradient of the line. It's allowed. Okay, but remember, I've told you, anytime you have English and math, write the math first, followed by the English. Okay, and take note. Okay, equal to and is. Okay, they mean the same thing. You cannot write the two at the same time. So you cannot write is equal to. Is that clear?
Yes, please.
In math, is the same as equal to. So take note. All right. Okay, that was just by the way. So we are done with part A. We are going to look at B. Okay, any questions before we move on to B? Are we all fine? Okay, great. If that's the case, then we can move on to B. B, what are we giving? We've been given the equation 2x plus y, okay, plus 3 is equal to 0. Okay, so we label this as equation 1. Okay, now what do? Okay, we need to work on this one, meaning make y the subject before we can compare. So I can write from 1, and immediately I write from 1. I don't have to repeat this. It means whatever I'm going to write here, it means something has been done or something will be done to this, okay, equation that you have there. So I can write from 1, then come and write this. If you want to repeat this, then you have to rather write, take it 1, then you write it. However, immediately you write from 1, whatever you are going to write here should be different from this. So I'm making y the subject. Y term here is positive, so I maintain it. It's equal to move these 2 terms to the side. But the 2 terms, each of them will be negative. So it means I can start with any of them. So I'll write my minus 2x, okay, then minus 3. Okay, so at this point, I'm going to compare. So comparing, okay, what do? We are going to end, okay, I for 1. Okay, this is how I would have treated it. I would have, because this equation will not be the one that I'm going to compare directly. Okay, I won't label it. So I will just write it, and I know the first step, take y the subject. So I'll come and write, this implies. Then this, so it means implication will come here. Okay, then after that, I will come and write, label the resultant equation here 1 and write comparing it. But that doesn't mean if you present your solution this way, okay, there will be issue. Only that in this case, if I write from 1, then I have to come and write maybe 1a. Then I write comparing 1a. Okay, you have to be more definite with, okay, the gradient intercept form, which is y is equal to mx, okay, plus c. Okay, and here we realize that you can go there. So I continue, otherwise you come down. So in this case, we are going to get, this implies that, or you can write comma here and write the m and its values that way. So if you compare, it implies that m will be equal to -2. So therefore, -2 is equal to what? The gradient. All correct? Hello, is my point well made?
Yes, please.
Okay, very good. So the next one, I am going to present it, okay, more maturedly. Okay, so let's see. So meaning definitely I'll take some of the steps out. So the C, okay, what are we giving? We've been giving, okay, 2y. Okay, even this one is a special situation. Okay, I should have done that with the b, but it doesn't really matter. It's equal to 0. Okay, so this is what we are going to do. I can still make my point here. We know there is a y term. Make y the subject. So I'm going to make y the subject. So y term here is positive. So I'll write, this implies that, okay, 2y, okay, is equal to what? -4. Okay, making y the subject, a term here, I have to divide both sides by 2. So I will get y is equal to 2y is equal to -4. I write it again over 2 over 2, remember. So y will be equal to -2. Is that clear? Okay, however, here we could have concluded just from the equation, but I just want us to subject this one to, okay, the steps because we can. Once there is y term, you can make y term. However, okay, we need to extract the coefficient of x as what? As our gradient. But there is no term in x. It means what we have here is the same as plus 0x. Are you with me?
Yes, please.
Okay, so at this point, I'm matured. I know that the coefficient of x is what I'm supposed to pick as my gradient. So I'll come and write, therefore, I won't compare it with anything. I will do the comparison mentally. Is that clear? So I'll write, therefore, 0 is equal to what? The gradient. Okay, but take note. Remember, okay, in the notes that I gave you, when I introduced you to this concept, finding a gradient, okay, of a line given its equation, I told you that if your equation does not contain a term in x, what will be the gradient?
0.
0. So immediately, okay, you have the, so let's look at alternative method. And this will be the matured way. Okay, the very matured way of dealing with it. So you extract giving, okay, with your question number, so which is C. Okay, giving what? 2y plus what? 4 is equal to 0. I realize that what I have here, there is no S term. So straight away, I know my gradient because we've been told the special situation where there is no S term, the gradient automatically will be 0. So I write therefore, okay, 0 is equal to what? Gradient. Okay, and in order, okay, for us not to more or less, in order for you to convince us that you know exactly what you've written here, okay, or in order for us to be convinced, okay, you attach your reason. Okay, since, okay, there is, okay, no, okay, term in X. Or simply put, you can write, since there is no X term, it's the same thing. Is that clear? Okay, Blaze.
Mr. Akman, when we use the second method, we are not going to be looking right the subject.
You are not going to.
Marks for not making
No,
right the
you
subject.
know, I've told you some of these questions, you don't have to. If you lose mass, I will tell you. Okay, that don't do it this way. This is only for objective purposes. Once I write it and I'm silent on that, it means, okay, you can equally do it. Remember, the marks, not for you. The marks will be mine as well. Okay, and you should know by now, you should know, it doesn't really matter how much you write. Okay, so it's not how much you write that will give you your marks. It's how much, okay, important stuff that you write that will give you, or critical step that you write that will give you, okay, your marks. All correct. Okay, so that's why here the reason is very critical. Okay, attach your reason for us to know that you know your stuff and you get the full score. No worries. Okay, maturity in this. Otherwise, okay, we are not encouraging maturity. Okay, so if that's the case, then we can move on to, okay, so this one, okay, to the next set of questions. So question 2, unlike the first question, okay, you can see that with this one, the equations are not that pretty. Okay, the equations involve fractions, but it's the same concept. Your change of subject should be good, that's all. Once your change of subject is good, the rest will just be comparing. You just compare, okay, and pick the coefficient of your X as what your gradient. However, I will go back a little. Okay, so we didn't do the D. The D will be for you. Okay, this D will be for you. Okay, and take note. What will be the gradient here? Just by looking at it. What will be the gradient? Infinity, undefined. The gradient will be undefined because there is no term in Y. Remember, I've given you all the tools. So that's the more reason why, okay, once I know that I've given you all the tools, I've given you all the advice, and you write something else, okay, that one, I won't spare you. I will write, think before you write, or don't just write, or be very careful, because it's like you are throwing our marks away. Okay, just for nothing. So please take note. It is for your own good for you to be cautious. Don't take it personal. All right. Okay, so this is what I have. All right, so or we have. Let's move on to the solution. Okay, slide. So now what do we have? Okay, again, question 2, we are finding the gradients. And question 2I, this time around is not A. So your numbering should be done accordingly and appropriately. So we extract our given equation. And what equation are we giving? We are giving 1 over 3, okay, X, okay, plus 1 over 2y minus 2 is equal to 0. Okay, so please, what will you do? Assuming you are going to do change of subject here, what will be your first step? Because you know okay, we are supposed to change or make y the subject. Okay, so in making y the subject, what do you do? Put up your hand and you tell me what you will do. In such a situation, what will you do first? Hello, my professors, are you there?
Yes, please.
Okay, especially I think I have to be your Kofi, are you there? I just remember that, okay, you are my TA when it comes to, okay, coordinate geometry 1. So what will you do? Kofi.
You send 1/3x to the other side with the 2, -2.
Perfect. Okay. So I know most of you will say that clear the fraction. It's allowed. There's nothing wrong with that. However, always, anytime you are doing change of subject, just isolate the term. Okay. That is containing the variable that you are making the subject, if possible. First of all, isolate it before you think about clearing fractions or brackets. Okay, so here, what do I have? I can isolate. So my TA, okay, has done the job. Okay, so if I'm isolating, this is positive, so I'll maintain it here. I'll maintain the half. Okay, this is an equation. Let me write this implies. Okay, I'll maintain the half y. Okay, then move the other 2 to the side. But the other 2, you know that if you move this will be negative. This will be positive. It's better we write the positive first. Is that clear? Is my point well made?
Yes, please.
Okay, and at this point, you know, you want the coefficient of y to be what? To be positive 1. So it means we have to multiply through by 2. Is that clear?
Yes, please.
Okay, very good. So now what do we get? And because one side contains more than a term, you can always do your multiplication mentally. So it's this 1 times 2, which will give us y, is equal to this 1 times 2, which will give us what? 4. This 1 times 2 give us 2 on 3x. Is that correct? Hello, is that correct?
Yes, please.
Okay, very good. So at this point, you can clearly take your gradient. So you write therefore, the gradient is the coefficient of x, and that will be, what's the gradient?
-2.
Okay, don't forget the negative. -2 on 3. Very good. Is equal to what? Gradient. So take note of that. Okay, those of you who would want to clear the fraction, you have to multiply through by the LCM, which is what? 6. You end up getting the same result anyway as the gradient. Point well made.
Thank you.
Okay, so, all right. So, okay, between I and I, which one do you want us to do? Okay, if you are not, okay, then I will do the selection for you. Okay, I'm going to do I. Okay. So I. Okay, you said. So given we extract, what are we giving? Okay, x over 3, and that's the same as 1 over 3x. Okay, minus what? Y over 2, and that's the same as what? 1 over 2y minus 1 is equal to what? 0. So with this one, to the same concept, isolate the term in y or multiply through by the LCM. Okay, but I'm going to isolate. So this y term is negative. Okay, so if I'm isolating it here, I always want to avoid negative. Okay, then it means I will move it to the side and make it positive rather than maintaining it here and moving this to the other side. It will still be isolated though. It will be isolated with negative, and I want to avoid that. Is my point well made?
Yes, please.
Great. Okay, so I am going to move. Okay, so I'm going to get, okay, x. This implies that x over 3 minus what? 1. Okay, is equal to what? Y over 2. Okay, is that clear? So now again, we have to clear the fraction here, meaning we have to make this y. And if you want to make this one, you have to multiply by 2. Okay, so if you are multiplying this by 2, all the terms here should also be multiplied by 2 to keep the equal to sign valid. Okay, so in that case, this 1 times 2 will give me 2 on 3x, or 2x on 3. Then minus this 1 times 2 will give me 2 is equal to this 1 times 2 will give me y. Okay, so this time around y is here, but don't worry, you can still pick your x, coefficient of x, I mean. So therefore, the coefficient of x here is for 2 on 3. Okay, and that will be equal to our gradient. All correct?
Yes,
It's my
please.
point well made. Okay, so the II and IV will be for you. You try that one, okay, later. Okay, or even let me pause. Okay, try the II. Okay, and give me your answers. You mean recording? Okay, so now we are back. Please, what did you get? Let me call you at random and see. Okay, immediately I get different values, then you'll see if you settle on the right one. Okay, Beverly, what did you get? What did you get as the gradient?
Mr. Hackman, I got -8 out of 9.
-8/9. Okay. All right, Efe, what did you get?
Sir, please, I got -8/9.
Okay. Joe, what did you get? Okay, so I think that is supposed to be the answer since we are getting. That's not to say that all of you cannot get it wrong. Okay, but okay, I know you are right. Okay, so Ivan, what did you get? Gifty, what did you get? Gifty, are you there? What did you get? Gifty, we are waiting. What did you get? If you don't respond, I will take it like you are not here. So I'll remove you. If you don't have the answer, at least you can tell me that you respond and tell Mr. Ackman I'm not done, or I don't know the answer. But if you are quiet, I'll assume you've joined and you've left the meeting. So I will equally do the needful. Okay, I'll come back to you again if you don't respond. So I've given you yellow card. Next time I'll remove you. Okay, Matiti.
Mr. Hackman, please, I just joined, so I don't.
So you mean you came this very late?
Yes.
You owe me one knock. All right. Okay, so let me see. Marlene. Marlene, what did you get? Oh, please hurry up. Marlene, too, you are not responding. Okay, so I know who to remove now. Okay. Vanna, let's go. What did you get? Oh, it seems your line is bad. Please, okay, send your answer via chat for me. Okay, Rich Love, what did you get? Rich Love, are you there? What did you get? Please unmute and respond. If you don't respond, I'll remove you, then report you to your parents. The other time you saw what happened. In fact, you heard what happened. Okay, I'll come back again. These three girls, okay, they are on my radar. Okay, so if I come back again and they don't respond. Okay, Foriwa. Foriwa, are you there? Okay, so Foriwa 2 has joined. Please, can you hear me?
Yes, please.
Okay, very good. So it means they are not responding. Okay. All right. Saida. Let's go. What did you get for IV, the gradient?
Negative 8/9.
Negative 8/9, the same gradient as the first one, as the II.
That's what I'm talking about.
No, IV. I've moved on to IV.
I've not solved that one.
Oh, I asked you to do this too, and I gave you 3 minutes. Okay. All right. Okay, Valikem, let's go. IV.
Sir, please, I've not done it.
Oh, so what were you waiting for? I asked you to do, please, didn't I tell you to do II and IV? And I gave you 3 minutes.
Yes, please.
Yes, please.
All right. Okay. Don't worry. I know your type. Okay. So in any case, okay, you will do it just because we are a little behind time. You will do it, and I'm so sure you get your answer. If you have any issues, we can discuss that later. Okay. All right. Okay. Anyone? Okay. Please, if you are through with this, call your value for me, and let's see, maybe as a guide, we will know that that's what we are supposed to get. Those of you done, what did you get?
Please, I got 8/9.
The same 8/9 for the IV.
Yes. I didn't get negative. This is positive
Okay,
8/9.
this is positive 8/9. I think, yes, it makes sense. Okay, because what you have here, originally you can see it is moved. Okay, all right, so that will be it, okay, for finding the gradients, okay, when giving the equation of the line. So now to our next concept, okay, parallel and perpendicular lines. Parallel and perpendicular lines. Okay, so here again, it is not new to you. It's a concept that we know already in AHS. Okay, then we are going to, okay, build on that, especially your presentation here in SHS. Okay, so 2 lines A, B, and C, D are said to be, so even if I didn't write lines and I wrote A, B, and C, D, you should know that A, B is referring to a line, C, D is also a line. So you will still read it as, okay, 2 lines A, B, and C, D without this are said to be parallel if they have the same gradient, and you know this. Okay, that is, so the statement that you have in maths, sorry, in English here, you are going to write it in maths. So that is if AB, the line AB is parallel to, you know, that is the symbol or notation for parallel, CD, then M, gradient of AB, that is M sub AB, is equal to M sub CD, gradient of the line CD. Is my point well made?
Yes.
So that's it for the parallel lines. Now let's come to the perpendicular lines. This one too, you know. So I'm basically going to be, ordinarily I would have asked you to give me what you know. Okay, but again, because of time, okay, I'm going to read, okay, straight away. 2 lines A, B, and C, D are said to be perpendicular if the product of their gradients is -1, or their gradients are negative reciprocal of each other. Okay, so that is if, okay, line AB is perpendicular to line CD. Okay, then the gradient of the line AB times the gradient of the line CD should be equal to -1. So the product of the two gradients should give you -1. Take note, not 1. And this is where the second part of the statement is coming from. okay, the gradients, okay, or they are negative reciprocal of each other. The gradients are negative reciprocal of each other. So by that, this is what we mean. If you look at this statement that you have here, the mathematical relation that we have here, if I make MAB the subject, won't I get M sub AB to be equal to minus 1 over M sub CD? Okay, if you are making M sub AB the subject, what do? You have to write it again and divide both sides by M sub CD. So M sub CD will cancel here, and this one you'll be left with minus 1 over M sub CD. Is my point well made?
Yes.
Or, okay, if you make, okay, M sub CD the subject, okay, what are we going to get? I'm waiting. What do you think we will get?
Negative 1 over M sub AB.
Okay, so please, do you agree?
Yes, please.
So we get negative 1 over M sub what? AB. Okay, very good. All right, okay, so well done. So here, obviously, we can see from these two statements, okay, derived from the main statement here, that the gradients are negative reciprocal of each other. So MAB, the gradient of AB, is the negative reciprocal of the gradient of CD. And the gradient of CD is the negative reciprocal of the gradient of AB. So the gradients, okay, are negative reciprocal of each other. Is the point well made now?
Yes, please.
Okay, very good. So quickly, let's go and make use of this concept, okay, in dealing with what? The following, okay, questions. Okay, so the first question, determine whether or not line AB is parallel or perpendicular to line CD. So here you are giving points. Okay, and if you want to know the grade, we know if you want to determine perpendicular parallel, what do we use? We use the gradient, is that not it? So once you know the point A and the point B, okay, we can find the gradient of the line AB. And we know the point C and the point D. We can equally find the gradient of the line joining was CD or the line CD. So quickly, let's go and do that and use the values of these gradients, okay, to make that determination. Okay, so solution. You want to determine parallel or perpendicular. Okay, you underline that. So now, what do we have? Solution to question 1, major question number. There is a sub question number A. Okay, so given, you can choose to write given, okay, or not, but I'm going to write given. Maybe subsequently I'll realize that what I have there will be lengthy, it won't go there, and I don't want to have a spillover. It doesn't matter though if you have a spillover. So given A, the point A with the coordinates 3, 1. Okay, so B, okay, with the coordinate 4, 2. Okay, C, okay, with the coordinate also 4, 2. Okay, and okay, D, if you like, you can still write comma. And D, okay, the 0.543. So I've been able to manage, okay, for all my points to go there. Okay, I believe you can see what I've written clearly.
Yes, please.
Okay, very good. Okay, so now at this point, we want to determine whether the line AB, CD parallel or perpendicular. And we'll need the gradients. We have to go and find the gradient of AB, the gradient of what? Of CD. So I will come and write but. Okay, the gradient of AB, M sub AB, we know will be equal to change in Y over change in X. So this will be X sub 1, Y sub 1, X sub 2, Y sub 2. So change in Y will give us 2 minus what? 1. Y sub 2 minus Y sub 1 over change in X. S sub 2 minus S sub 1. So 4 minus what? 3. Which in effect will give us, remember, as you are writing next line, right close to the margin. So numerator will be 2 minus 1, which is what? 2. Okay, denominator will be 4 minus what? 2 minus 1, which is 1. Forgive me. Okay, so let me clear that quickly. Okay, all right. I guess somebody was ready to draw my attention to that. Okay. Okay, so now, okay, 1 all over, let me see. Okay, so all over 1. As you mature, you can move from here to the 1 straight away. Without any time the denominator is 1, you can choose not to write it. Okay, so that will be it for AB, MAB, the gradient of AB. Now, and the gradient of what? CD, MCD. Remember, I've told you, you're supposed to be small m. Is equal to, so with this one, CD, X1, Y1, S2, Y2. Finding the gradient, giving 2 points per aspect. So we shouldn't waste time on this. So it will give us 3 minus 2. Okay, change in Y. Y2 minus Y1 over S2, which is 5. Okay, minus X1, which is 4. Okay, so this also will give us, okay, 3 minus 2, which is 1. 5 minus 4, which is over 1. You don't write it. Just leave it like that, like I mentioned here. Okay, so at this point, we are going to have our conclusion done. So looking at the 2 values of the gradient, okay, MAB gave us 1, MCD gave us 1. So what conclusion can we draw? What will be the nature of the lines? Parallel or perpendicular?
Parallel. Parallel.
Parallel. Okay. All right. Okay. So you are going to get parallel. Okay. Very good. So you draw your conclusion as such. Okay. So you write, this is how you conclude mathematically. Therefore, your line AB, okay, don't write parallel in words. Okay. Just use the notation parallel. Okay. To the line. Okay. CD. And if you like, you can back it to the reason. Since, okay, MAB is equal to what? MCD. All correct. And remember, your letters here, none of them should be a small letter. Okay, points are denoted by capital letters, not small letters. Okay, you know yourself. Don't repeat that. Okay, is my point well made?
Yes, please.
Okay, so at this point, we move on to, okay, the B. Okay, or let me even do the C. Then you try the B again and the D. Is that okay?
Yes, please.
Okay, so I am going to move on to the C. Okay, so C, what are we giving? Okay, the point A. Okay, let me. Okay, all right. Remember, I've told you in math, somebody asked a question whether the reason is optional. In math, okay, if you want to let us know that, okay, you didn't just guess, you know what you are about. Okay, if you can attach a reason to any statement, attach. Especially when it is not obvious. Okay, if you have stated from the beginning that, okay, for line AB to be parallel to line CD, okay, then MAB should be equal to M what? CD. In this case, when you get here and you come and draw your conclusion here without the reason, we know the preamble is there. So we can use the preamble, okay, to draw that conclusion or to attach that reason ourselves. However, okay, here there is no preamble. So attach your reason. You found gradient. So how come you are saying that it's parallel to this? You get the point. And you attach this, and that makes, okay, the statement here more rich. Is that clear? Or richer? Okay, I guess my point is well made. Thank you. Okay. All right. So now I'm giving A 2, negative what? 2. Okay, B with the coordinates -1, -4. C, okay, with the coordinates, okay, -3, 2. Okay, and D, so I want to use, I know that if I write N, it won't go there, so I will use comma. And D1, okay, -1. Okay, so now we know. So this time round, I am going to write, I know I will use the gradient to determine parallel or perpendicular. So I'll write but my gradient AB, I can choose not to write the but and write implication. This implies MAB. Okay, is the same thing. So, but MAB, or this implies MAB, will be equal to minus 4, changing y, minus 4, minus 4, okay, plus 2. All over changing x, minus 1, okay, minus 2. So that gives us our numerator to be negative 2, the denominator to be negative 3. But this and this can cancel, so you'll be left with what? Okay, 2 on 3. All correct. Okay,
Yes,
and okay, your second gradient, which is the gradient of the second line, CD. Okay, that will also be changing y. So x1, y1, s2, y2. So minus 1, minus 2. So minus 1, minus 2. All over changing x1 minus 3. So it will be 1 plus 3. Okay, which in effect will give us minus 3 over, okay, 4. Is that clear? Okay, so at this point, the 2 points, sorry, the 2 gradients are not the same. Okay, and let's check. If they are not the same, it means they are not parallel. Okay, if they are not parallel, then it means they intersect. However, if they intersect at an angle of 90, then the product of the 2 gradients here should be what? Negative 1. Or the 2 gradients should be negative reciprocal of each other. So let's look at the product giving us negative 1, the main, okay, relation. So in this case, my first gradient is 2 on 3 times my second gradient is what? Minus 3 on what? On 4. Okay, so this will cancel this. This will go here 2. So I'm going to get what? Minus 1 over 2. So the product is giving me or giving us minus 1 over 2 instead of 1. So it means, okay, the line is also not perpendicular, or the lines are not perpendicular, I should say. Is that clear?
yes, please.
So look at how we are going to draw our conclusion. It's because of the conclusion that, okay, I am, okay, doing this particular one. Other than that, I would have left you. Okay, so in this case, what do we have? We will say, first of all, we realize that, okay, line AB, okay, parallel is this. Okay, so how do you think we will write not parallel? If you know, you put up your hand. How would you indicate not parallel in terms of notation? Let me see if you can be smart. Okay, anyone? Okay, I know if I guide you, you'll be able to do it. Okay, so this is equal to, how do you indicate not equal to?
You draw a line to like
You
this.
cancel, you draw a diagonal line to cancel. So the same thing, draw a diagonal line to cancel this. You get it? Math is so simple. The same language. So anytime you are referring to not, you cancel. That's notation. So here, this will be read as AB is not parallel to CD. Line AB is not parallel to line CD. Okay, and okay, again, we know that line AB is not perpendicular, so it's perpendicular is this. Okay, CD. So if it's not perpendicular, what do we do?
Cancel.
You cancel, you draw a diagonal line through that, and it will be read not perpendicular, AB not perpendicular to CD. All correct?
Yes, please.
Okay, great. Any questions at this point? Okay, and usually these kind of questions, okay, you will get it in objective, but that's not to say that you can't get it in subjective, okay, situation. Okay, so you could be given the gradient of one line and you'll be asked to find, okay, you'll be given points and you'll be asked to find the gradient of what? Of the line joining the 2 points, which will be perpendicular to the already given gradient. Okay, so if you are fine, then we can move on to our next concept. Okay, all right. Here we are going to look at how to determine, okay, Matilda.
Mr. Hackman,
Mm-hmm.
please, I can't see the sign.
In between the AB and the CD.
Is it the second one?
Yes, please.
Okay, so you know in math, in geometry, we use this to indicate perpendicular. Okay, just as you saw. Okay, remember in the introduction, I introduced that. Can you see?
Yes, please.
Okay, all right. But because you will use your free hand, okay, the reason why we attach, you can see that in the notation that I showed you here, okay, there is no 90 indicated here because we can obviously see that this vertical line, this horizontal line. However, when you are, okay, using your free hand, okay, you are unable to. So that's the more reason why you indicate the 90 so that we'll know that this is vertical, this is horizontal. So that's the difference. You get it?
Yes, please. Thank
Okay, you are welcome. Okay, so now to what? Okay, Liz.
Mr. Please, when you're finding the product, are you supposed to do it as rough work or as
Yes,
part of
yes. That's why I did that. Okay, so do that as a rough way. All right, okay, thank you. All right, so now let's look at our second. Do you have another question?
Yes, please. And
Okay.
are we supposed to do it on the work so we cancel it to prove that that's
As a rough work and you cancel? Yes, that's what I said. It's a rough work, and every rough work, unless it's a vital rough work, must be cancelled. Even vital rough work, if you cancel, no issues, because you cancel in such a way that it will still be readable, whether vital or not vital. So if there are marks, okay, like allocated there, you will definitely get it.
Okay, thank you.
Okay, all right. Okay, so please, okay, if it's about capturing, let's move on. We are a little behind time. Okay, you get the video, unless you want to ask a question. But if it's not a question from the previous slide, okay, please let's move on. Okay, I plead. Okay, we have to finish, okay, what we are supposed to do today. Or when I give you your water break, I can go back and you capture. Is that okay?
Yes, please.
Okay, thanks for your understanding. Okay, so now to question 2. Okay, so question 2, the same, okay, concept. How to determine whether lines are parallel or perpendicular. So determine whether or not the following pairs of lines are parallel or perpendicular. Okay, so you get the video and you watch. Okay, take notes. All right. Okay, so now this is what we have. For the first set of questions, you were given points, and we know how to determine gradient from points. So we're able to do that and use, okay, the conditions, okay, for perpendicular and for parallel. Okay, so now this is what we are going to do with this situation. This time around, instead of points, you've been given equations, okay, of lines, and we need to determine whether, okay, the lines, okay, with these equations will be parallel or perpendicular. And we know all that we need to do is to extract the gradient. Whether we are given points or we are given equation of a line, we now know how to find the gradient. Is that clear?
Yes, please.
Okay, so we are going to make use of the first concept that we learned today. Okay, apply it here again. So solution question 2. Again, if you like, you can underline parallel, perpendicular. Okay, so 2A. Let's extract what we are given, 2 equations. So given the first equation is what? Is 3x plus what? Y is equal to 4. And remember in math, anytime you are given more than an equation, label the equation. So 1. And your second equation, or our second equation, y is equal to, okay, 2 minus 3x. So you call this equation 2. Okay. Now, you know, in order to determine parallel and perpendicular, we need the gradient of each of the lines. We'll compare and use, okay, the concept that we know, the conditions to draw, okay, our conclusion. So in this case, If you want to find the gradient of a line given its equation, we know what to do. So go and pick equation 1. You write it in the gradient intercept form. Okay, so from 1, and again, once it's from 1, you don't write this exactly same here. You have to do something to it. So from 1, we are making y the subject. Y is positive here, so it will be maintained there. It's equal to move this one to the side. And don't write making y the subject. I've already just write this. Your steps will let us know exactly what you are doing. Okay, so now this is what you have. So from here, we know that I can say that this implies my gradient. Okay, and here I will write therefore. Okay, so take note. So my gradient. Yes, please.
3 is 3 and not 2.
Okay, so now you are following. Okay, so you are with me. So it will be minus 3x. Okay, so at this point, you are going to get m to be equal to minus 3. Do you agree?
Yes, please.
Okay,
Yes,
remember
please.
this one, you are not asked directly to find m. So you cannot conclude with m. Take note, that's the difference. Okay, so here, because I'm going to find 2 m's, okay, I need to distinguish between them. Because this m is coming from equation 1, I write this as m sub 1. Is that clear? It's my point well made. Then from, you go to 2. So from equation 2, okay, comma, we are going to make y the subject, but y is already made a subject. So with this one, we can pick our gradients that way. So I'll write m sub 2 will be equal to minus 3. All correct?
Yes, please.
Okay, so at this point, m sub 1, m sub 2, they are the same, right? So
Yes,
it tells us that the lines are perpendicular, true or false?
True.
Hey,
Oh,
someone was caught in my web. All right, okay, it's false. Okay, once the gradients are the same, really they are parallel. So now you go and draw your conclusion. Okay, so therefore, okay, in this case, you write, because you didn't have the point to write maybe A, B, C, D, just write the lines. So you write therefore the lines are, okay, parallel, or you use the notation parallel. Okay, if you like, again, you can attach your reasons since they have the same gradient. So let me write that since, okay, they have the same gradients. Or since their gradients are the same. Is that clear?
Yes.
Okay, so we are going to look at that of what? Of the B. Okay, and I think that will be it. Okay, or let's do that of the C. Okay, so C, you come down, you leave a line. Okay, what are we giving? Okay, your first equation is y minus 3x, okay, minus 2. Okay, is equal to 0. So you label this as equation 1. And, okay, your second equation is y, okay, plus 3x, okay, is equal to minus 1, equation 2. Okay, so from 1, we need the gradient. So let's go and find the gradient of equation 1. Okay, so from 1, we make y the subject. Y will be equal to, move this one, these 2 to the other side. So you get 3x, okay, plus 2. Okay, so this implies, okay, my m, if I compare mentally, m sub 1 will be equal to 3. All correct. Then from, okay, equation 2, I'm going to make y the subject. So y will be equal to,
minus 3x.
okay, minus, okay, 3x. Okay, then minus 1. Is that clear?
yes.
Okay, so in this case, I can say that this implies that my m sub 2 is equal to what? Minus 3. Okay, are the two gradients the same?
No, please.
Okay.
No,
And would the product give us -1?
no.
The product will give you
Yes,
what?
please.
Hey, did I hear yes? The product will give you -9, not -1.
Yes, yes.
So be careful. All right. Okay. So, all right. So now this is what we have. So we can draw our strong conclusion. Therefore, the lines are neither parallel nor perpendicular. All correct. Point well made.
Yes.
Yes.
Great. Okay, if that's the case, then I think we are going to pause here, have our water break. We'll come and continue. So by 8:30, we should all be back. Okay, so welcome back from the water break. We are now going to look at, our last but one concept, which will be finding the point of intersection of two lines. And I know with this one too, you have, an idea, of it. Okay, so I know usually, what you do in JHS, you are told whenever you are finding the point of intersection of two lines, you solve the equation simultaneously. Is that not it? The equations of the given line simultaneously. So that's the method one, your known method. You solve the system of equations formed by the equations of the two lines simultaneously, either by using the elimination or the substitution method. I hope it's clear. That's what you know, right?
Yes, please.
Okay, I'll walk you through another way, then we make that determination. Whichever one sits well with you, you adapt. Method two. Okay, this is what you do. First step of method two, express the two equations for the lines in the slope-intercept form. Slope-intercept form, which is the same as the gradient-intercept form. Okay, remember where we are coming from. If you want to find the gradient, we have to write the equation in the slope-intercept form, which we have. So we know how to do this. Okay, though after writing it in the slope-intercept form, we are not going to use that to get what the slope or the gradient. Okay, but this is what you do next. Step two, set the two equations for y, equal to each other. So your two equations, if you write them in the slope-intercept form, all of them will be y is equal to y is equal to. You get the point? Because you make y the subject whilst you are writing it in the slope-intercept form. So you get y is equal to in the first equation. Okay, the resultant equation for the second one will also be y is equal to. Now, what you do is equate these two y's. So it's like y is equal to a, assuming, or if a is equal to b and a is equal to c, then it means what b is equal to c. That's the concept that we are going to use here. Then solve for x. After solving for x, you use the x to solve for y. And you have to substitute this x into any of the two original equations before you solve for what your y. So very soon you know that it's so easy, to work with these steps. So quickly, let's go and look at what the questions that will require the use of the concept that we just learned. Okay, so we are supposed to find the point of intersection of the following pairs of lines. Point of intersection. Okay, so pairs of lines. Okay, A up to what? Up to E. So maybe I will do two questions. Yeah, the first one will use both methods, and the second one that I will handle together with you, maybe we'll decide on one of the methods. Okay, all right. So because usually you will not be restricted as to the method to use. Okay, so quickly let's go and have a look at what's the solution. Okay. So now let's see. We are supposed to find the point of intersection. So point of intersection, be very critical about this. Okay, because sometimes the question can ask you to find, the x coordinates of the point of intersection. So in that case, you solve for only x and conclude with x. Or the y coordinate of the point of intersection, you solve for only y and conclude with y. But if the question is looking for the point of intersection, then it means the question needs both x and what and y. But you have to put these two values in the point form. So don't conclude by saying therefore x is equal to this, y is equal to that. Take note. Your answer must be in the point form because we're asked to find a point. Only there is a point of intersection. Take note. So please, this is what we are going to do. Solution. There is no major question number, but minor question number A. Okay, then what do? We extract. What are we giving? Please mute. Okay, if you are not given the opportunity to talk. Okay, so what do we have? Given our first equation is x minus y is equal to 1. Okay, equation 1. Okay, and okay, if your second equation will go here, continue. Mine will not go there, so I'll come down. My second equation is 3x, okay, plus what? 2y is equal to what? 8. So this becomes my equation 2. Okay, so now we are good to go. You want to use method 1. Okay, with method 1, we need to solve these two equations simultaneously. So either by using elimination or substitution. If you want to eliminate, remember I've told you, listen to the equations. The equations will tell you the appropriate or the ideal method, okay, to use, be it elimination or substitution. So if elimination will be best, okay, the equation that you have there, directly you should have the x coefficients to be the same or the y coefficient to be the same, neglecting the signs. But immediately one of them not the same. If I want to eliminate x, this coefficient here is 1, coefficient here is 3, then it means I have to multiply this one of the equation by a constant. So I want to avoid that. I cannot do direct elimination unless I multiply. So elimination will not be ideal. So let's go to substitution. For substitution to be ideal, okay, your change of subject, the variable that you make the subject should involve a fraction. And thankfully, if you make x or y the subjects, none of them will involve a fraction. So it means having listened to the equations are telling us that it would be better for us to use the substitution method. However, if you want to use the elimination method, it's allowed. So for the substitution method, I have to make one of the variables the subject in any of the two equations. Here, equation 1 will be better. So I'll go and write from equation 1. I'm going to make, okay, if I make y the subject, then it means I will solve for x first. If I make x the subject, then I'll solve for y first. Okay, so let me make, okay, y the subject. So I'll make x the subject positively and move this one to the side. So I'm going to get x, okay, it's equal. It doesn't really matter which one you make the subject first, provided it will not involve a fraction. That's the way to go. Check the one that you are making the subject. Avoid fraction if possible. Okay, so it will give me 1 plus y, or y plus what? 1. You move this one to the side. So I will call this 1a. And go and substitute 1a into 2. Okay, so I'll write equation 1a. Don't write put. Don't write put. Don't write substitute. Substitute. Again, I'm saying this, okay, for obvious reasons. Okay, repetition is just for emphasis. Okay, so now into equation 2. This will always be too short, just like this. Don't let this take one line. So comma. Okay, then what do we have? We are going to substitute. We get 3 into x. X is more than a term. You put it in brackets. Hello. Okay, Amma.
Sir, please. But I thought you said elimination method would be the best.
No, I didn't say elimination. I didn't say that. Please, is that what I said?
Hey, sir, please, that's what I heard.
Then maybe you are hearing voices, not mine.
Okay.
Okay,
Then
I said if elimination would be best, then you should be able to eliminate by directly adding or subtracting without multiplying any of them by a constant, any of the equations. If substitution will be best, then the variable, you should have a variable that if you make the subject, it will not involve a fraction.
Okay.
All right, okay. So we'll get 1 plus y here. Okay, so now it's equal to, plus, okay, let me go and clear this. Okay, so plus 2y. Okay, is equal to 8. So now we come and remove the brackets here, which will give us 3 plus 3y. Okay, plus 2y is equal to 8. So we end up getting 5y. We are making y the subject. Move this one to the side. 8 minus 5, that is 3. Oh, sorry, 5, forgive me. 8 minus 3, rather. I said 8 minus 5, and that will give you 5. Write it again before you divide. Never forget this. Some of you still will forget. Please, okay, obedience is better than sacrifice. So y will be equal to what? 1 here. But you need y to predict your s. So you label this as equation 3. And go and write equation 3 into, okay, the equation that you made as the subject. That is equation 1a. Okay, so now you have x will be equal to 1 plus y, which is 1. So don't write equal to 2 here, come down. Equal to 2. Avoid writing more than 1. Okay, equal to on the same line. Okay, all right, if possible. So now you know the x and the y. So we can conclude by writing, therefore, okay, the point of intersection is, please don't write that. Okay, come and write the point of intersection first. So x coordinate is what must come first. Please take notes. The fact that you found y first and x doesn't mean y is what you start with. It's always x, y. So x, what is the value of x? 2. What's the value of y? 1. Okay, is the point of intersection. Or I can write equal to point of intersection. All correct?
Yes.
Yes,
Okay,
please.
very good. Okay, now let's go and look at method 2. Okay, if you remember method 2, we said in each of the equations, you make y the subject, meaning you write it in the gradient intercept form. So I'm going to write from 1. Okay, y will be equal to, if I make y the subject, I'm going to get, okay, 1 plus x, am I right? Or x plus 1. Okay, then from 2, I equally make y the subject. So if I'm making y the subject, I maintain this term here, which is 2y. And it should be equal to 8. Then I move this one here. So it should be 8 minus 3x. All correct?
Yes, please.
Okay, I'm not done making y the subject. Okay, I'm writing it in the gradient intercept form. So I have to divide each of the terms here by 2. Okay, Nenekia.
Mr. Ackman, please. The second one you're writing. What
Mm-hmm.
if you do it mentally and then like y stands alone?
No, you are
Like you
making
don't write
what you are making y the subject. So take us through your change of subject.
No, Mr. Ackman, I mean like when let's say you do the subject thing, you do it mentally. And then come
That's
and
why I'm
write
saying.
it, then will you lose
That's why
Hey,
exactly I said. Okay, take us through how, if you do it mentally, are you taking us through how you got it? No, you get it. So I understood your question and I answered it perfectly. All right.
Thank
Okay.
you.
You're welcome. So walk us through how you got it. So you do exactly what I'm doing. Okay. So if it's an objective question, fine. You can skip certain steps. Okay. So now you write 2y, okay, is equal to 8, okay, minus what, 3, okay, x. Okay, one way is to consider this as a term and divide by what, 2. Consider this as a term, divide by 2. That is one way. So you get y is equal to what? 8 minus 3x all over what? Over 2. However, because, okay, I will not do it this way, because remember we said you write it in the gradient intercept form. In this form, it's a single fraction, but the gradient intercept form is partial fraction. Is that clear? So meaning, okay, I'm going to write this, but I'll tell you something. This over 2 is 4. Okay, this over 2, which gives us minus 3 on 2x. Is my point well made? However, if you write it this way, okay, here you are not going to extract any gradient. So even if you leave it at this point and you go and equate, you won't lose any marks. Only that I just want us to be consistent. We said the gradient intercept form. Or I can also say that okay, make y the subject in each of the equation. In that case, I don't mind whether you leave it in the gradient intercept form or whichever form. What is important is y is made a subject. Is that clear?
Yes.
Okay, so at this point, I have two y's. The first y is this. Okay, the second y is this. So if y is equal to this, and the same y is equal to this, then it implies that this is equal to that. Is that clear?
Yes, please.
Okay, like I said,
That one, please come again.
if A is equal to B, and the same A is equal to C, can't we say that it means B is equal to C?
Yes.
Okay, so just a simple math. Okay, all right. So if you get this, then I can say that this implies that, okay, my first y, which is 1 plus x, should be equal to my second y, which is 4, okay, minus 3 on 2x. Please take note, like I said, you can still use this y. So if you want to use this y, this is where you end with a y. You don't come here. Is my point well made, Liz?
Mr. Kwan, please, for the first one, then from 1, the 1, y is equal to 1 plus x. 1 is supposed to be negative.
Let me see. Y is equal to, oh, good, very good. Okay, I moved as if I made y the subject. Okay, sorry. Okay, so I see if I made, okay, in any case, whichever that I made, one of them will be negative. So please, this one, the spot is intentional. Okay, all right. So let me clear this. So it's supposed to be y is equal to x minus 1 instead. Is that clear? So this must go. Hello, are you with me?
Yes, please.
Okay, so it means this can also happen to you, so be careful. So y, I move y here, so that will give me x minus 1. So I'm going to get what? X minus 1. Okay, then x minus 1 here as well. So now you can see that my equation is only in x, so I solve for x. So if I'm solving for x, I have to isolate the x or collect the terms in x on one side or clear the fraction. So I'm going to clear the fraction. So this will give me 2x minus 2 is equal to 8, okay, minus 3x, all correct. Multiply each term by 2, the LCM. So in this case, I will move this one to the side. So it's 2x plus 3x, that will give me 5x. It's equal to, I'll move this one to the side. Okay, that will give me 8, okay, plus what? Plus 2, and that is 10. I write it again before I divide. All correct?
Yes, please.
Very good. So you get x to be equal to 2 here. But you need x to predict your y. So you call this equation. Okay, have you labeled? Yes, equation 1 and 2. So this becomes equation 3. Then you go and write equation 3 into, okay, which of the equations? Any of the two original equations. However, you can see that equation 1 is easier to relate with. It's prettier. Okay, so into equation 1. And that will give you, this implies that we are going to get what? X, which is 2, minus y is equal to what? 1. So if I continue to the next page, I will get y to be equal to what? Y to be equal to, okay. However, please take notes. Okay, in the notes you were told that substitute that into the original equation. I am going to refine that now. Okay, after solving for x, come and substitute that into any of the equation that you made y the subject. Okay, exactly. But because you didn't label this equation, that's why if you have labeled this equation, it will be better. So immediately you realize that you are going to substitute that one into this, come and label this so that you can walk us through, okay, easily, coherently, okay, we can understand what you have there. So that's exactly my point. But I've already done the substitution here. So I won't, okay, clean it. Okay, so now I just gave you an additional information. So I am going to, I think I can get my y here. So I will move the y here, and this will give me, okay, 2 minus 1. So I will get y to be equal to what? 1. Is that clear? Okay, then comfortably, you come and draw your conclusion. So therefore, okay, you were asked to find the point of intersection. So the x gave us 2, the y gave us 1 is equal to point of intersection. Okay, all right. So with this, we are good to go. And like I said, we are going to do, okay, one more. Okay, so let's see. Okay, so D. Okay, what are we given? We've been given our first equation, which is what? Okay, x minus y is equal to 1. Okay, equation 1. And our second equation, you come down, it won't go there, which is x minus 5y is equal to what? Negative 3. Okay, so that becomes our equation 2. So with this equation, I realize that I can easily eliminate x. So I want to use the first method simultaneously, solving simultaneously. So I can easily eliminate x because the coefficients are the same. So I will use the elimination method. Amma, is it clear?
Yes, please.
Okay, so because they have the coefficients have the same sign, +1, we'll subtract to eliminate. However, if you eliminate x, your result will be in terms of y. And remember the advice. Okay, make sure you subtract in such, because we subtract to eliminate. Subtract in such a way that your y term here will be positive, so that you avoid one step, which will be curing the negative. So if I do this one minus this, okay, 1 minus 5. So that will give me a positive number. So I would rather do equation 1 minus equation 2. So I will do 1 minus what? 2. Okay, comma. So that will give me x minus s. That will go minus y minus 5y. So minus y plus 5y, which will give you 4y. All correct. And that will be equal to 1 minus 3. So 1 plus 3, which is what? 4. So again, you write it again before you divide. Okay, over 4. Okay, so y will be equal to what? 1. Okay, so now what do? We label this as equation 3, and we use 3 to predict what? Okay, x. So I'll write equation 3 into any of the 2 original equations, but this would be better. Okay, because it equals smaller values. So into equation 1, comma. So that will give us what? X minus 1 is equal to what? Is equal to 1. So this implies that I will get x to be equal to 1 plus 1, which is 2. So again, I'm going to get, okay, my point of intersection will be, okay, 2, okay, 1. That's not to say all points of intersection will be 2, 1, or I beg. Is that clear?
Yes.
Okay, so it's equal to
Yes,
points of intersection. Okay, so, okay, only that this time right, A and B, the 2 points of intersection coincide, they are the same. Okay, so that will be, so with that, you should be able to do the rest of the questions. Okay, is my point well made? Any questions at this point? Hello, any questions? All right, okay, we thank God. Okay, so Adoma and Amma. Okay, so after Adoma, Amma.
Okay, Mr. Hackman, please, yesterday, did you receive my message?
Your message? Oh,
Yes,
we are
please.
talking about this. So you are talking about yesterday's message.
Mr. Hack, please, it's like,
let's restrict ourselves to this. Okay, if it's related to this, fine. But if it's not related, then we can shelve it for another time. Okay. Those of you who came early, remember I gave you the opportunity to ask questions. Okay, so next time come early. And Aduma, you are always early. I don't know what happened today. Today you came early, oh? Okay, Amma.
no, please, thanks.
Okay, so what was your question? Just say it. Then move on. I'm now going to check. You know, I have a lot of messages. So if you say, did I see what if I see it, you know that I've seen it once it's paused up. So if I tell
No,
you I did,
like I told you that I will not be able to join today's class, so I came a little bit early. That's why I joined late. So I wanted to know if maybe you can send me the video right after the class, like personally.
Okay. So I now remember. Okay, your message. So that's why you could have given me. You know, I'm aging. Okay, so please pardon my age.
Yes, please.
Okay, all right. The video, but I told you that I'll send you the video. Watch the video. So this one is patched. I mean, cancelled. You know, we had a deal. Who said he had a deal? Okay, I've seen your class. All right. Okay, all right. So that will be it. Amma.
Mr. Ackman, please, you said you've refined something, and now we shouldn't, when we get a variable, we shouldn't substitute into the main equation.
Yes,
we should
because
rather...
let me make it very clear. The reason why, okay, you know that the two equations, each of them, you make y the subject. When you equate, you always solve for x. When you solve for x, okay, if you come and substitute them into the original equation, after substitution, you have to solve for y. We have to make y the subject. However, if you come and substitute that into any of these two equations, you can see that already y is made the subject. So you get your value straight away. That's why I was giving you that advice.
Yes. So, Mr. Ackman, if we name the y is equal to x minus 1, 1a, then we are doing the implied 2. I'm saying we've given it a name, so won't it affect the part that we write the implied 2?
Oh, no. If you give it a name, if you give this a name, okay, you know this is y. We know that you are equating your y. Okay, maybe you also come and give this one. I'm just saying maybe you come in this one, give this one to a name, maybe 2a. So once y is equal to y, then it means 1a is equal to what, 2a. You can write that and equate, or you can just equate mentally like we did directly. We know the equations that we are supposed to equate or form with the equal to.
Okay.
All right. Okay, great. Any other? Eracy?
Mr. Huffman, please, good morning.
Good morning.
Please, so the two methods that are on the screen right now, which one would you advise that we should use?
Okay. The two methods that we've done now, okay, which one would you advise yourself to use?
Well, for me personally, I feel maybe the method one would be okay.
Yes, because method one, that is the one that you'll be dealing with. Okay, so you are too familiar. And you can see that indirectly I answered that question. The second question, which method did I use? If you have studied my okay, what do you call it, strategy or way of teaching, you would have known that I will always go for the ideal one. When I teach, I take you through more than a method.
Thank you very much.
Okay, so that's the more reason why I went for the first method here. Afa. Okay, great. Adoma, you should be tired. Your hand is still up. Please bring it down. All right. Okay, unless you have another question. Okay. Amma.
Mr. Ackman, please, about the determination of a line being parallel or perpendicular. What if we get the lines being perpendicular? How will we conclude? Like
hello,
parallel,
Amma. Hello, Amma.
Yeah. Yes. Hello.
Okay, no problem. If it's parallel, you write AB is parallel to CD, or the lines are parallel. Okay, or if they are perpendicular, AB, you know the notation. Once you know how to conclude not parallel, you should know no parallel. So CD, as simple as that.
So we shouldn't add any statement to it.
Oh, you should ask the statement. Okay, the statement will be, if it is this way, you can write, okay, since MAB times MCD is equal to -1.
Okay.
So indirectly, I said it. Okay, all right. You know the condition that made you had that conclusion done, so it shouldn't be a problem. I guess we can move on now. The last concept. Okay, All right. So let's see, 10 minutes, if I can use the 10 minutes to do this. In actual fact, I have 5 minutes. I always want to give you at least 5 minutes to prepare for your next lesson. But okay, quickly, let's look at equations of parallel and perpendicular lines. Okay, so one, equation of parallel line is given by, so parallel line, this would be the equation, the usual equation. Okay, so y minus y1 is equal to m, okay, into x minus x sub 1. Okay, and I've told you once I say x1, y1, you know it's sub, because I started by saying that. Then 2, equation of perpendicular line is given by y minus y sub 1 is equal to minus 1 over m into x minus x sub 1. In some books, okay, the minus will not be here, to be in the numerator. There is nothing wrong with that. So you see minus 1, the whole of that over m is the same thing. Okay, don't get it twisted. Okay, so here where your m is the gradient of the given line. So the given line, if its gradient is m, the power line will have the same gradient. So that's why we substitute the gradient here. However, if the original gradient is m, the gradient of the given line is m, we know that the gradient of the perpendicular line will be negative reciprocal of the gradient of the given line. So that's why we have negative 1 over m here. And that will be it. So just know how to quote these. This is for parallel, this is for perpendicular. You are good to go. All correct?
Yes.
Okay, so quickly, let's come and look at, okay, the following questions. Because of time, I will solve one question each. Okay, just to guide you as to how to do your presentation. So find the equations of the line which are parallels. We are looking at the parallel line. Okay, to the given lines through the point stated. Okay, so this line through this point, parallel to this line through this point. So quickly, let's go and have a look at what's the solution. Okay, so solution to question 1, and like I said, we underline parallel. We are finding the equation of the parallel lines. We extract, what are we given? And we are dealing with A, the sub question A. Okay, we've been given, okay, y is equal to 3 minus x. Okay, and the point, if you like, I know I will need a gradient, okay, to determine, okay, my equation. So I will call this maybe equation 1, because I have to come and work on it. If you like, you can write and, okay, or you write comma or semicolon, column, then you come and extract your point. Minus 1, okay, minus 3, the x and y coordinates. So quote the formula. Every question that involves a formula, after extracting the information, quote the formula, remember. Here, equation of, okay, the power line, you know, will be given by y minus y1 is equal to m into x minus x sub 1. All correct? Okay, your x sub 1, y sub 1 will be the point that your line is passing through or lying on the line. So x sub 1, y sub 1, that one directly given. By your m, it's not directly given. Okay, so this m here is the gradient. Remember, we said is the gradient of the given line. So in this case, we go and find m from the equation here. So I'll write from, okay, 1. Okay, my m will be equal to negative 1. Do you agree? The coefficient of x, because
Yes,
it's already in the gradient intercept form. So at this point, I'll write, this implies that, okay, y minus y1, y1 is minus 3, so minus 3 is equal to my gradient, which is minus 1, into x minus x1. x1 is minus 1, so it will be plus 1, minus minus. All correct?
Yes.
Okay, so at this point, you know, equation of a line, any line that you are asked to find its equation, okay, it should always be in a particular form. That's the standard form. Everything on one side equated to 0, making sure that your leading term, which is the term in x, coefficient positive. So we remove all brackets and remove all fractions, if any. Okay, so this would be equal to minus x minus 1. The x here is negative, so it means we have to move these terms to the side. So whilst moving, I'll draw my conclusion. So x, okay, plus y, and this one will be 3 plus 1, so plus 4. Okay, it's equal to 0. So this is the equation you end there. Afa.
Yes, please.
Okay, so with this, okay, can I choose not to do one more? Is your understanding okay?
Yes.
So, okay, then let me move on to the second question. I will equally do one here. So find the equation of the line this time around, perpendicular line, okay, to the lines to, okay, the point stated. So let's go and look at the solution. Okay, so you underline perpendicular. Okay, that will guide you as to the formula to use. Okay, so again, you underline perpendicular here. Okay, which you have underlined there. So solution to question 2A. Okay, so what are we giving? We've been giving, okay, let me do, okay, you let me do this. It's okay, let me do the A. All right, so 3, okay, minus, oh, sorry, Y is equal to, I'm still having this feeling of doing the B. Should I do the B instead? Because it's the same. Why? So that when you are getting the gradient here, you know how to get the gradient. So I will do the B. Is that okay?
Yes, please.
Okay, great. So quickly, let me go and do the B. Okay, so this will be B instead of A. Okay, so B. Okay, so what do we have? Okay, at the normal circumstance, because of time, I should have done the A. Okay, so that I know we've done the gradient there, so we can infer. Okay, but no problem, is the understanding that I want. So this becomes equation 1, I will need it. And my point, okay, is what? 1, okay, 0. Okay, so at this point, what do I do? Okay, I know I'm finding the equation of what? Perpendicular line. So I'll quote the formula. Equation of what? Perpendicular line. So perpendicular line. We know is given by the formula y minus, I know you can go there, so that's why I'm continuing. If you don't go there, come down. Minus 1 over m into x minus x sub 1. All correct?
Yes.
Okay, x sub 1 we know. Okay, y sub 1 we know, the given points that passing through. So the gradient is what we don't know directly, but we can get it from this line. So we go to from, so it's like, that's why I say quote the formula and let the formula lead you as to what to. So after quoting the formula is telling us that we'll need m. Okay, so we'll go and find m. So from 1, comma, okay, we make y the subject. So I'll move this one to the side. So in my mind, I've moved it to the side. I'm bringing this one here. So it's equal to 2x minus 5. All correct?
Yes.
Okay, so this implies that my m will be the coefficient of x, which is 2. Okay, so now I'm going to have this implies, okay, I come and substitute y, y minus y1. y1 is 0, forgive me, is equal to minus 1 over m, and m is what? 2. Okay, into, okay, x minus x sub 1. x sub 1 is 1. All correct?
Yes, please.
Okay, so at this point, I'm going to multiply, clear the fraction. Okay, multiply through by 2. Okay, so I'm going to get, okay, 2y minus 0. I won't write it. The 2 will cancel, so I will get minus into x minus 1. Remove the bracket, so 2y is equal to minus x plus 1. Then this is negative. To guide me, I have to move this one. So first moving, I combine and draw my conclusion. So I'll get x plus y will still be here, 2y, and this will come minus 1. It's equal to 0. So is the equation. Point well made.
Yes, please.
Okay, so elective math students especially take notes of this. You will need it in the coordinate geometry. Okay, parallel and perpendicular lines, how to extract their equations. Okay, so at this point, if you don't have any questions, okay, thank you very much. Okay, once again, I believe the lesson has been, okay, very successful. Okay, so God bless us all. Bye-bye.